All right, class, welcome to Math 2020, handout for section 1.1, which is about points, lines, and planes. And so this is a video which I will explain each part of the handout for this lesson. First of all, we are going to start with geometry basics. So points, lines, and planes are kind of the basics. We start out with a few rules, and we're going to use deductive thinking to help us extend these basic ideas to other ideas. And so deductive thinking is taking one thing and then deducing another and then deducing another from those things, kind of like in a chain. So you have a logical argument. First of all, we're going to begin with what is a point. So a point is a zero-dimensional object. It can be also referred to as a location, or a location. And it has no length, no width, and no height. Okay. 0 dimensions, so there's no attributes to measure with it. Okay, so you can think of it as a location, just a spot. You know, another word is, you can say a spot somewhere. Just okay. And our example, let's go ahead and do our example in green here. The example of a point is usually indicated with this dot, okay, and it's just that spot. So even though the dot is like a little circle, the actual object of a point does not have any length or width or height. Okay. And so we're going to continue on with what is a line. Okay, so this is kind of like a little bit abstract because a line is actually consisting of infinitely many points. Okay, and since points don't have any width or anything like that, it's kind of hard to imagine what one is. But if you were to put all of these, a bunch of points or a bunch of locations in a straight row, then you have a line. Okay, so a line is a one-dimensional object. Consisting of infinitely many points. Okay, and it doesn't have any thickness. Okay, so there is no thickness or no so without thickness. That extends forever. In both directions. Okay, and so there's only one dimension to think about here. Okay. And our example here for a line. So all of my points are there. See, I have one here, one here, one here, one here, and I can put them all, bring some of them out, and notice that they go all infinitely many of them. Okay, so that's why it kind of looks like a line, a straight like object that way. Okay, so that's a line, goes on forever in this direction here, goes on forever in this direction here. Okay, so we indicate that with arrows, meaning that it goes on forever. All right, so now we're going to do something with these two objects. Draw one point on your paper. Okay, so I'm going to draw a point, dot, and name it A. Okay, points are named with capital letters. Okay, so if we talk about an object here, like A, we know it's a point because it's a capital letter. Okay, and so we want to use our ruler and draw in as many lines as we can through point A. Okay, so let's go ahead and start drawing in some lines here. So there's my ruler here. I'm going to pretend I have a ruler since I'm drawing this freehand. Okay, so you draw one that way, draw one this way. Okay, and I'm going to keep drawing them in here. And I'm going to keep going through this point here, as many lines as we can through this point. So notice that we can just keep going forever because every line I can do a one in the middle of each one there. Draw another one in the middle of this one. Okay, and so we can conclude that you can draw an infinity amount of lines through point A. So you can draw an infinite amount of points or lines through point A. Okay. All right, so here's another exercise with those. Draw two new points on your paper, name them B and C, and use your ruler. How many lines can you draw through both B and C? So I'm going to draw my point B here and my point C here. And how many lines can I draw through them? Well, if I want to go through both of them, I can only do one line through those, okay? And so, since I kind of missed that one, I'll draw that bigger. Okay, so I can only draw one line through those points. So you can draw one line through 2 points because 2 points determine a unique line. Okay. Going on to page 2. Now use your ruler for number 5 here. Use your ruler, draw a line and name it AB. Okay, so lines are written with two capital after their points, two of the unique points in the lines with capital letters, and then they have up here, on the top of those, they have like a little line drawn and their symbol. Okay, so that's what we're introducing is some notation. We're going to draw 2 points here. There's a point A, and here's a point B, and we're going to draw a line through those right here. Okay, we're naming the line AB. Okay, so there's my line AB. What is a line segment, or just segment is what they really call it. So we'll talk about segments. And so a segment is a part of the line between 2 points. Okay, so we have a part of the line between 2 points on the line. Okay, and we're going to do an example here. Okay, so the example, we just have like point here, point here. Okay, so there are 2 points and everything that's in between them, which is also consisting of points, right? There's a bunch of points in there. Okay, infinitely many between that. So use your ruler, draw a line segment. Okay, so I'm going to use my ruler and draw a line segment and name it CD. So I'm going to put point C here, put point D here, and I'm going to draw a line segment. Okay, so it's all the points in between there. Notice that as we draw as we refer to this segment with capital letters, we have the capital letters from the points, and then we have this part above here, which is a little line but no points or arrows. So just a little line compared to our arrows up here with the line. This one just has a dash and no arrow ends. Okay, so that means that is CD. What is array? Okay. Array is a part of the line on one side of a point on the line. Okay. A part of a line on one side of a point on the line. Okay, and so we have our example here. Okay, we're going to draw a point here, and it's just one side of the line here, one side of the point. So that means we extend the rest of it forever. So it's like a line that has a starting point and no ending point. Okay, so use your ruler, draw a ray, and name it DE. Okay, so rays are have a beginning point, and that's going to be the D, and there's going to be some other point on the ray that's E. Now we know that after E, we have the ray that goes on forever. So note that that is different than ray. So we're going to note this. Oops, let's go ahead and use our symbols. Ray ED is going to be different than DE because we need the beginning of our symbol here has to be with the letter. That's going to be starting point of our ray right there. Okay. So ED is going to be this ray. This is E and this is D. Okay. Or it could be drawn like this, going back this way. The ED is going to be with this point there and that point there. Okay. So that's how you name arrays. What is a plane? Okay. So a plane is something like this, where we have a fuselage, we have wings, and we have a tail. And it flies through the air, right? Zoom, zoom, zoom. No, it's not that kind of plane. Nope, not that one. We're talking about a plane in geometry, okay? Geometry, geometrical. Oops. Geometrical. Okay, plane. That's what we're thinking of. And that is a two-dimensional object, okay? Consisting of infinite lines, okay? That extend forever in a length direction and a width direction. Two directions. Okay. And so our example here, draw up an example where we're going to start extending lines here. We're going to start putting lines side by side. Now, lines, of course, don't have any thickness. Okay, so we'll pretend that they when you put a bunch of them together, they'll start doing that. This is a little bit abstract. In the length direction and the width direction. So here's these two directions that we have them. Okay, so when you start doing that, they kind of all merge together here, and what you have is just like a space here that has a length and width, a flat surface. Okay, so it becomes a flat surface. Okay. Now, because there are lines on here, we also have points on here. Okay, and so there's points also in here. So you can find a location on the plane or a flat surface within the lines, which is within the plane. Okay, so planes are a pretty complex object, but we can make sense of it. And what we'll do with planes is that we'll mostly find. We won't do too much with planes really, but we'll talk about them later when we get to area in chapter 5. We're going to draw 3 collinear points. Now, collinear is the word here that we're learning. So a lot of these things in geometry are just definitions, okay? So collinear points. I'm going to draw these points. So you're going to label them A, B, and C. Okay, and they're collinear because they all are on the same line. Okay, so line is the key part of that word collinear. Okay, I'm going to draw a line through these. Okay, so there's the line that goes through all three of those points. They're collinear. Okay, so we can say that A, B, and C, okay, those are all capital letters, are collinear because they all lie on the line AC. So I'm just going to pick two of the points and then put that there like that. Put the little arrows. Okay. Draw three non-collinear points. Describe how your points are non-collinear. So non-collinear means that they do not lie on the same line. So I'm going to just draw in some points here, random points. Okay. And we have A, B, and C again are non-collinear because no single line can be drawn through all those points. Okay, so no single line can be drawn through all 3 points. Okay. It's non-collinear. Draw a picture to illustrate that lengths along a line add together. Okay. So I'm going to draw a picture with a line and 3 points, A, B, and C. The 3 points will be sufficient to illustrate this principle. Okay, so A, B, and C are collinear. Lengths along a line. Now, lengths mean the segments. Okay, so we're talking about this part right here. This part right here. So we're going to add these segments together. So they're lengths along the line. So we're going to say that segment AB plus segment BC. Okay, so here's segment AB right here, plus segment BC is equal to segment AC, okay, or the entire thing here. That's segment AC. Okay, so from A to C. So line lengths add, so segment lengths add. So we can add this part to this part and get this whole thing. Okay. Last one, draw a picture to illustrate that in any triangle, the length of the longest side is less than the total length of the other 2 sides. Okay. So we're going to draw a triangle here, and you can do this by finding non-collinear points. Okay, if you're connecting 3 non-collinear points, we will have a triangle. Okay, so connect that to that, that to that, that to that, and a triangle. We'll talk more about triangles in another section. Okay, so for example, we have AB plus, this is AB, plus BC, and that's BC right here, is equal to, is not equal to anything, but it's greater than. Okay, so we want to show that the 2 sides are greater than the 3rd side. Okay, so we say greater than AC. Okay, so notice that those 2 segments here are bigger than this one. Okay, so we're going to move on to example number 2. Try segment AB. So we'll start with this one again. Plus segment BC, or AC. So here's the other one. And that's going to be, has to be greater than segment BC. Okay. And then our last one we can think about, or just another final one here. Segment AB plus segment, we've used all those ones. Let's go back to segment VC. Let's start with that one, BC. Okay, so segment BC here plus segment AC is going to be greater than AB. Okay, there we go. So we got these three here. Okay, so that's what we're having for our lesson, and I hope that you guys enjoyed it. Just some basics to start out with, and look forward to seeing you guys in the homework.